Can you hear me?
Switch, right?
Hello?
Yes, can hear you perfectly. Well, good morning, everyone. Hello, and welcome to today's UNU-INWEH Science Talk. My name is Dr. Rohit Ramchandani, UNU-INWEH's Innovation and Strategic Partnerships Officer, and I'm thrilled to be your host today, standing in for Dr. Miriam Axel. For those of you new to Science Talks, our weekly series showcases the exciting research of UNU-INWEH and our experts. I'm pleased to share that all of our previous Science Talks are available on demand. You can watch all of them on our website and YouTube channel at unu.edu/INWEH, that's INWEH/science-talks. Today's talk, like all others, will be recorded, and the video will be made available after the session. We'll conclude with an interactive question and answer period, so please feel free to share your questions in the chat prior to the end of the talk. Today's talk is entitled Evidence of the Contribution of Transportation-Related Air Pollution, or TRAP, to Urban Air Quality, a Persistent Global Challenge. And today's speaker is Dr. Vahid Hosseini, an expert in sustainable urban transportation. His research explores the intricate connections between transportation systems, air quality, and public health, examining how to transform urban mobility to achieve net zero emissions while ensuring accessibility and resilience to climate change. As the urban transportation and air quality lead at UNU-INWEH, Dr. Hosseini leads research, capacity building, and policy development initiatives that focus on how decarbonization strategies can contribute to cleaner, healthier, and more equitable cities around the world. Dr. Hosseini holds a PhD in mechanical engineering from the University of Alberta and serves as an associate professor at the School of Sustainable Energy Engineering at Simon Fraser University. Please join me in welcoming Dr. Hosseini. Dr. Hosseini, the floor is yours.
Thank you very much. Good morning, good afternoon, everyone. So let me share my screen. Can you hear me all right?
We can, yes.
Okay, and then let me know when you see the presentation.
Good to go.
Good to go. All right. Good day, everyone. Thank you very much for the invite. Thank you for the opportunity, UNU-INWEH, and very nice meeting everyone. My name is Vahid Hosseini. I am an associate professor of a School of Sustainable Energy Engineering here at Simon Fraser University. Today, I want to talk about the contribution of transportation to air pollution in the cities. And instead of presenting one or two specific projects, I collectively show what we have done as researchers in the last 10, 15 years on issues of the air pollution related to transportation, showing you a couple of different projects, different methodologies that we employ, and then the implications for the decarbonization of the transportation sector in cities. It's food for thought. So apologies if I jump back and forth between different projects here in this presentation. But before that, I want to talk about our brand new school. It's a School of Sustainable Energy Engineering here in Surrey, British Columbia, Canada. You may not heard of it. It's a school that started, it's around 2020, so less than or about 5 years old. Here's the picture of our building in downtown Surrey, and all we do is research on sustainable energy, different aspects of sustainable energy. Very exciting school to be at. And my part is looking into environmental impact assessment and air pollution in this school. As you can see, we have multiple programs of research-based, thesis-based, and so on. So if you're interested, you can scan the QR code and learn about our amazing school. And even before that, to go to the research, I want to acknowledge the contribution of all of my graduate students over the years. I've been working in multiple academic institutions so far, Sharif University in Tehran, University of Alberta in Alberta, and since 2021 in Simon Fraser University. This is the picture of my current lab, but in the background, you see so many alumni contributors to this research that I present today. So I'm really grateful and indebted to all of them for their dedication, creativity, and hard work that they have done, and they're doing it right now towards the research on air pollution related to transportation sector. The lab that I'm leading here at SFU is Collaborative Research on Energy, Air Pollution, Transportation, and Environment, or for short, CREATE. And then really what motivates our research on transportation-related air pollution, or for short, TRAP. We all know that transportation is a major source of air pollution. By the way, decarbonization that is happening in the transportation sector is really uneven. Out of probably 2 billion vehicles out there in the world, less than half of them are being considered for any sort of decarbonization, including electrification, and the rest of them have no clue or no direction or no policy about what holds in the future of decarbonizing the transportation sector. And then we heard about new fuels, low carbon fuels, no carbon fuels, and they all bring new emission challenges to our cities. And then as we do electrification in a few cities around the world, we also see the impact of non-exhaust emissions being even more than before in our air pollution. And then exposure inequality really persists. People are not exposed to emissions from transportation equally, while the network is connected everyone. But I'll show you in a bit that how it impacts different communities differently. And we really want to quantify, understand, and then see whether we can inform policies to reduce transportation-related air pollution in the current world and in the future of decarbonized transportation world. Before I show you a couple of research directions we are taking, I want to make the distinction between emissions versus pollution. They're interconnected, but they're distinct in terms of the research that we do. And I normally have this slide as a background slide to show to everyone that if you look at these two circles on the left, you see the emission sources, which are stationary, area, line sources, industry, dust, and so on. And as you can see, mobile sources, transportation is there, aviation, railroad, marine pollution. So that's emission. And as you can see, the unit that we do a study and measure is in mass. So we talk about kilograms and tons and grams and so on. And normally the unit is like that. And then I have a little icon of a car on top that shows a little car with a plume. So when you see that icon, it means that an emission study. But those emission sources actually emit the emissions into the air, and then we have the weather impact, we have the atmospheric chemistry impact. What people are really exposed to is not emissions, it's pollution. And you see the icon of that person is exposed to particles, and you can see the pollution. And then we measure the pollution with air quality monitoring stations, as shown in one of the pictures below in the slide. And the units are different. As you can see, it's microgram per meter cube, or parts per million, or parts per billion, or percent. So it's mostly mixing ratio, molar ratio, and things like that. So really going from emission to pollution, it's a complex weather and chemistry impact that we have to always consider. And that part is always very difficult to explain to elected officials and politicians about the changes that they have to make to the transportation sector. Policies and programs works on emission, the impact will be on pollution. By the way, that picture of the air quality monitoring station belongs to Alberta Capital Airshed. As a reference, they did a very interesting project. Check out their website. It's in Alberta, Canada, and they actually put artwork by individual artists on all of the air quality monitoring stations. I found it very, very cool initiative. And now that begs the question with this introduction that the emission standards are really good. Vehicles are clean, and we are also decarbonizing. Is it really a significant source of air pollution in communities? And by that, just as an example that how clean we are in terms of transportation emission, if you look at this chart, you'll see that particulate matter on the x-axis, nitrogen oxides on the y-axis, both of them toxic pollutants. And Euro 1, for example, in Euro was back in 1990s, and that was like all of the trucks, and this is truck actually emissions, and you notice the icon of emission on my slide. So it was supposed to be in this blue box. And then as we move forward to 2000s and 2010, as you can see, Euro 2 and Euro 3 and Euro 4 and Euro 5 and Euro 6 and now Euro 7, we are really at the corner of this plot right now in terms of new vehicles that are being registered in our system. So we're really close to 0, 0. And just take a look at these numbers. We came a very long way in terms of reducing emissions from fossil fuel cars. So we have done really, really good. But activities is a lot. So if you have clean vehicles or relatively clean vehicles, but you run them around and you drive them around, still the total will be really high. This especially is a big issue in big cities with lots of cars and lots of vehicles and trucks. And then fleets are outdated. We are talking about new fleet, but old cars and old trucks and old vehicles are already on the road in many parts of the world. They are not really getting renewed as they're supposed to be. And then some people do not take care of their vehicles. There's issue of tampering. I'll show a slide about that. Some even, taking the emission control devices and filters from the exhaust of their vehicles. So that's an issue. Many parts of the world's fuel quality is not up to standard. Even if it is, I've seen instances and I've worked in projects that people start mixing all sorts of different substandard fuel with the fuel just for the cost, and then that increases the emissions. And in real world, vehicle performance is not really what is measured in the lab. So there's also that known fact, and I also have a slide in a bit to show you. So it still is an issue, despite of the fact that we are at the 0, 0 corner of that plot. It seems that we're still struggling with the emissions. Now, speaking to that, how much contribution? This is one of my older work in Tehran, Iran papers, as you can see in 2022 and 2016. But it just tells you a story that if you look at the left-hand side plot and you look at all of the pollutants that we counted for in our emission inventory calculation, and the reference of the papers are there, you can check. There's total suspended particles, PM10, PM2.5, both of them particles, NOx, SOx, carbon monoxide, and volatile organic compounds. They're all gases. And as you can see, the blue part that I kind of highlighted with the red dash actually makes up a major part of all of the emissions in that mega city. It's like 12 million people are living there. There's so many sources, and you'd be surprised that, for example, almost all of carbon monoxide is from transportation. More than half of particles is from transportation. And this is, by the way, still emission. It's not pollution. There are some extra that will be added when you calculate the pollution side. And then on the right-hand side, you can see the details of these NOx, CO, VOC, SOx, etc., from different type of the cars and light-duty vehicles versus heavy-duty vehicles, public transit versus taxi or trucks. They emit differently, and they're responsible for different part of the pollution. So still isn't a problem in many cities. This is an example. I just keep bringing on many examples for you. One of them is another work that I do with World Bank on South Asia, and this is one of the most polluted regions of the world. In some instances, the annual average PM2.5, as you can see in my slide, reaches 100 microgram per meter cube. And just to give you a context, WHO recommends 5 microgram per meter cube to be the safe limit. So 100 microgram versus 5. So it's quite an issue. And then 2 million premature deaths annually in South Asia just by ambient air pollution. It's quite daunting number, as you can see on this slide. Is it all from transportation? No, there is industrial sources. There is so many coal burning, crop burning is a big issue there, of course. But if you zoom in some of the cities, for example, again, I'm collaborating with World Bank on a project in the city of Lahore, Pakistan. You will see that about 30% of the pollution comes from transportation. I did a back of a napkin calculation for how much like emission factors are different from their current fleet versus if it's supposed to be progressing, as well as, for example, Euro emission standards. You see in the plot that currently they have a gap of, order of magnitudes. By the way, the plot is in logarithmic scale, so 10 to 100 they're well behind in terms of emission standards, as you can see, and of course the old vehicle, but authorities and the country is moving toward cleaner transportation. You can see this picture that I took in Lahore, it shows the new electric bus is being added to the city, and then at the same time you see one of these old rickshaw three-wheelers that one of the major source of the pollutions. So it's in Tehran, it's in Lahore, it's in Mumbai, it's many cities around the world. But what if, we were talking about those? What if about the cities that they have cleaner vehicles? Going back home, let's take a look at Canada. This is the great work of Professor Greg Evans at University of Toronto. They're doing a lot of roadside studies and have started publishing many papers. This report that I'm referring to is 2019, but they still have much newer reports. But as you can see, 80% of NO and 60% of black carbon near road come from local vehicles. And that's quite high, because black carbon is a highly toxic substance, part of the PM 2.5 or part of the particles. And as you can see, even in cities like Toronto and Vancouver, still as an issue. And then you can see the exposure on the roadside, the numbers that I put here. Even we learned that cold weather in Canada actually contributes to NOx and particles. I have a project in city of Edmonton that we specifically look at cold climate emissions. And then this group actually continues with a large initiative, global initiative on non-tailpipe sources. So as vehicles become cleaner and cleaner and they're electrified, now the issue of tire particles and brake particles, etc., becomes more important than before. So not even in South Asia or Middle East or Africa, there's also issues in Canada and US and in Europe, as you can imagine. And we can just bring so many examples to take a look at transportation being a major part of air pollution in many cities. This is the study that we did in Metro Vancouver. Actually, the filters are collected by Metro Vancouver in downtown Vancouver and are analyzed by Environment Climate Change Canada. We ran a statistical model, and we learned that about 32% of the mass of the PM 2.5 comes from traffic sources. And here's the reference to the paper that we published in 2024. And still, the green part of that pie chart, if you look at that, it says 26.9, 27% secondary organic aerosol. And that's the pollution. That's the part that the chemistry actually generates more particles in the air. And of course, part of it also from transportation. Despite of the fact that Vancouver is a port and you expect to see a lot of contribution from marine, there's lots of industry, still traffic makes a big part of particle mass in Vancouver. So that's another example. I looked at other cities, Vancouver and Toronto are big cities. What about small cities? There are lots of studies on Edmonton, Calgary, almost most of the cities in Ontario and so on, to show that the contribution of the transportation, especially to roadside exposure, is pretty high. So here's my evidence of the contribution. Now, the next question that I'm asking is that, do the vehicle pollute the same way as in the lab? Because as I explained, the emission standards, we're really getting to the 0.0. The contribution is high, but what about the individual vehicles, how they perform on the road? And for this, we do a lot of portable emission measurement study. This is something that I have been doing for many long time and several experimental setup, but the idea is relatively simple. You put sensors on the car, as you can see, the yellow box, and you drive around and you collect information about the emissions of the vehicle on the road. Of course, it's tedious, it's expensive, it takes time to put sensors on a car, and then, the sample size is pretty limited. You can test probably a car in a week if everything goes right. So you don't collect so many samples in a given year. But everything intensified in terms of using PEMS RDE since Volkswagen actually cheated the emission cycle on a Dieselgate scandal in 2014, because their vehicles were performing very well in the lab and not so much on the road, probably 30 times higher, more NOx. And they got caught by PEMS RDE test. And now, at least in Europe, it's part of the regulation that vehicle manufacturers needs to do also PEMS RDE testing on the road on top of the testing that they do in the lab. Here is my experimental setup, or our experimental setup right now in our lab at Simon Fraser University. It's pretty complex setup. You see, the back of this UV is full of instrument. There's FTIR, there's particle counters, everything is heated, there's power supply, there's data acquisition system. So this is what we do right now, and just keep measuring different emission factors of different vehicles. Of course, in this particular study, we are very much interested in unregulated emissions, the emissions that are not regulated, for example, NH3 or formaldehyde, acetaldehyde, and so on, from different technologies of the vehicles, different fuels. The result, this is relatively old result back in 2016, the same study that I did in Tehran when I was at Sharif University. We tested 33 vehicles, and they were all Euro 2 certified at the time. Right now is Euro 4, Euro 5. But at the time, they were all Euro 2 certified, and they were all supposed to be in this red box that I showed in the plot in terms of carbon monoxide and unburned hydrocarbon and NOx. But as you can see, only 30% of the cars were actually performing Euro 2, and they were higher by a factor of 2 to 6 of different pollutants when they were driving. So you see the issue. We have so many cars, despite of good emission standards, they are not performing very well, and we keep measuring these and reporting these using our PEMS RDE research. Now, PEMS RDE is very time-consuming, labor-intensive, very expensive, tedious, and then you work for a year for this research. You collect 10 samples or 10 cars or 5 cars, something like that. It's not very easy to do PEMS RDE. We really want to look at the traffic as a whole and see like what vehicles do in collectively in terms of emissions. And for this, we did quite a bit of remote sensing studies. As you can see, this is one of our publications back in 2021. So what we do, we just install sensors on the roadside. And as you can see in this slide, in 14 days, 5 locations, we collected 24,000 samples. So as the vehicle passes by through our sensors, the license plate is captured. Later on, we check that what was the type of the vehicle. Was it gasoline, diesel, light duty, heavy duty? So from the license plate, you can extract that information from different databases. And then at the same time, you get a snapshot of the plume of the vehicle and come up with emissions. So this is the methodology that we have been using. And again, the results show that small fraction of the vehicles that we call them high emitters are responsible for most of the pollution. So it's not like that all of the vehicles equally contribute to the emission. 10% of the vehicles contribute to 60% of the emissions on CO and so on. So these kind of rules, 20/80, 10/90, 30/70, 30/50 really applies everywhere. There's always high emitters that they actually contribute a lot higher, and you can also see in the histogram distribution of the pollutions that a small fraction of vehicles are responsible for high emitters. So this is really to inform policies that you really don't need to go after the entire fleet and test everyone. You just need to test and monitor those high emitters and try to remove them off the road. Very good piece of work that actually informed multiple policies back in the days. Now, I also mentioned the issue of tampering. Unfortunately, people tend to start, okay, this exhaust of my diesel truck is very complicated. There are so many components in them. It slightly increases my fuel consumption, and then it breaks down. I need to fix it. I need to pay for fixing it. There's a downtime for my truck. So let's remove them all together. And because in Canada, for example, we don't have any annual emission testing. We used to have it in Ontario, in BC, and so on, but we don't anymore. So you can really, well, unfortunately, people can really move all of those nice, expensive filtration from their exhaust and then replace it with a piece of pipe and some few electronics that cheats the engine OBD, and then say, okay, drive. And here are the causes. And then I worked with ICCT on the report, as you can see on this slide, to actually calculate the tampering in Canada and the health impact of tampering through some modeling work. It's a very interesting study. I encourage you to take a look. But that's what people do. And CASA in Alberta, I collaborated with CASA, Clean Air Strategic Alliance, and OPUS. We did a study on tampering and high emitters of trucks. As you can see, here is a snapshot of a truck passing through our test sector, and we scanned so many vehicles, and one of my students generated this plot, and all of those green dots, as you can see, they're supposed to be at, within the limits, within the green box, but they're not, so they're high emitters. We are not saying that all of them are tampered exhaust. Some of them may be just high emitter for just an instance, but the project with CASA hopefully continues that we can actually get to the bottom of tampering. We expect that 10% or 15% tampering exists, and by the way, for those that they do tamper, the emissions can go as high as 10 times to 30 times higher of what it's supposed to be. So that's also part of the research that we do on high emitters. Now, from all of this, the next question that I'm trying to answer in my research or our research is that road connects everyone, but do traffic emissions impact all communities equally? So we've done individual vehicle emission measurement, fleet vehicle emission measurement. Let's put them together in a nice model. So we use MOVE's motor vehicle emission simulator. That's by US EPA. So basically takes account for everything: traffic volume, traffic speed, all of the cars in the road, activity of them, at which hour of the day, how many vehicles are on each road, and what are their speed, and so on. And then we put together everything in under this modeling system and come up with emissions per link or emissions per different part of the city. Some of my students, they actually take on of this a little bit further, and they look at the traffic cameras and identify type of the vehicles that are driving in each road. Of course, you're living in a city, some part of the city there are more trucks, some part of the city there are more light duty vehicles, and so on. So we want to account for that. So there's a little bit of image processing and AI work here to identify what type of vehicles are operating where. And then some of the students are even taking it up a little further and say, okay, what would be the impact in winter? For example, as I said in the project in Edmonton, like what if there is a snow on the ground, and what if there is a very freezing temperature? That changes the vehicle behavior, traffic, speed, emission factor, and so on, and we count all of that in. And here's some of the preliminary results. This is city of Edmonton, and this is PM 2.5 from truck, NOx from truck. And as you can see, it's completely unevenly distributed. And you can see those blue dots are populated areas. And of course, some communities are exposed much higher to these than the other ones. And it really depends on the type of the vehicles that are moving around and the traffic and so on. And then we also look at the communities and we try to rank them. And as you can see, they are color coded. The orange is for light duty, purple is for heavy duty, yellow is for public transit. And you look at the communities in Edmonton, for example, you look at the NOx and PM and carbon monoxide, you see the ranking is different, the type of pollutants that are exposed is different. So all of the policies that we make to clean up the transportation sector, for example, electrification of light duty vehicles that is going on, it will impact communities in many different ways. They're not being equally treated in terms of reducing the emissions from transportation. I show an example of policy directions that we're trying to make in terms of these emission calculations. This is the study that is currently under review. And as you can see, it's relatively a complex slide. I don't want you to look at the details, but what we did, we looked at the bike sharing. The idea is that what if we just reduce the vehicles kilometers travel, less vehicles on the road, and then promote mobility as a service and alternative ways of moving around? And bike sharing, carpooling, public transit is all sorts of different ways that you can reduce the car movements in the city. We did a modeling and calculation, and some part of it was AI modeling, some part of it was physics-based modeling, and we used moves. And we realized that we can actually achieve the same amount of decarbonization of CO2 reduction as per electrification of the car by bike sharing. So in a underutilized bike share system, if you have something around 15 to 18 bikes it actually can replace one fossil fuel car CO2 reduction. And that's significant. And by the way, this is an underutilized system. If you go, for example, to Montreal, or if you go to Paris or New York, it's a highly utilized bike sharing system. So every 6 bikes give you the same, almost the same benefit of reducing one vehicle being replaced by an electric car. And that is huge considering the infrastructure that is needed for electric vehicles, the cost of electric vehicles, and everything else that goes around. And it also contributed to congestion and non-exhaust emissions and so on. So this is very interesting finding that you'll see the publication very, very soon. Now, I talked about emissions so far, emission measurement, emission modeling, and so on. What about the pollution? So for that, we need to actually translate our emission to pollution. This is some of the work that we do that. So again, a map of the city of Tehran, but you can see the emissions are now graded. So we kind of do a CFD type of work, grid the emissions on the different cells. You can see different cells, they have different, color with respect to different emissions. We count now all of those sources, not transportation, because we want to look at the pollution. This is similar work done by one of my students. Here is my lab. It's for Metro Vancouver, and you can see the animation of the emission. So this emission, after being processed by a model that is called smoke, it's ready to be implemented into the chemistry and weather model. So really what we are looking is to translate emission to pollution, and that secondary path up there under unburned fuel, converting to secondary PM 2.5 is the one that makes it very interesting, and we really don't count on the emission study. We need further chemical analysis to analyze that. For that, we use other modeling system, for example, a weather model, WRF, a chemical transport model that accounts for the chemistry. It's CMAC, and we have been using these two models for the last few years. Some of the work, for example, in my previous work in Tehran, as you can see on the left-hand side is the gridded emission as I explained it. It accounts for all sources, and you can see the maps are different for different emissions. NOx is different from CO, from PM. On the right-hand side, you have actually the pollution map, and that's what we measure with our air quality monitoring stations. And now we can calculate how much population exposure happens when we have the pollution map. So this is the end of the modeling exercise. Another example, again, the pollution maps, Metro Vancouver. This is the model that is currently up and running in my group, and we account for everything. You can see the pollution moves, and that's of course because of the weather, wind, stability, everything is accounted for. Some maps of the pollution in Metro Vancouver area, and here on the left you can see NO2 map, so it shows which areas of Metro Vancouver have higher NO2, and my student actually identified the roads by looking at the map and not even knowing where are the roads, just by looking at the deep colored area. And as you can see, despite of the map being from all of the sources, stationary, industrial, everything, you can see that NO2 concentration is highly driven by the roads. And the same thing happened on the right-hand side if you look at the carbon monoxide map. Again, you can identify the major roads like Highway 1 and so on in this map, which is very interesting that you look at the pollution map, but you still see a signature of traffic and transportation in it. And then there are substances that are not accounted for in emissions. For example, ozone. Cars and transportation do not emit ozone. Ozone is actually a toxic pollutant that is generated in the air. But now our modeling system enables us to look at the ozone map. And this is again the work on the city of Edmonton. And as you can see, downtown and center communities that were exposed to higher emissions in my previous slides, now they're exposed to less ozone pollution, because for ozone to be generated in the atmosphere, it takes time. So you generate the emission at the city center, but the communities around the center are exposed to higher ozone, as you can see in this map. And there's a distinct difference between summer and winter, as you can see. And then we also, at the same time, we study the weather, and this is another work under review, which we look at the weather impact in certain cities in terms of their secondary organic aerosol, ozone, turbulent mixing, and so on. And this is just to showcase you the type of studies that we do on connecting the weather, climate, atmospheric chemistry to emissions from transportation. Now, the last question, or probably one of the last questions that I'm posing, and I'm trying to wrap this up in a few minutes, is that, okay, let's just wait for vehicle electrification. Everything will be resolved by itself. Everything will be electric. Of course, if you look at the right-hand side image, you can see that these are gas electric, these are electric cars, you know, the gas cars and electric cars, and there's not much of a big difference in terms of traffic. So this is an op-ed in Los Angeles Times that I took the picture, and it was a very interesting piece, but that begs the question that, okay, what happens when we electrify? First of all, EV adoption will not be the same across the board, and there are many, many studies that shows that different communities are doing the electrification differently. Setting aside those countries and cities and part of the world, and this is part of my talk at United Nations University, it really speaks to the world. Many parts of the world, they have no plan and no movement toward electrification. So setting aside those, for the ones that are doing it, they're doing it very unevenly. And as you can see, people of color are less likely to go toward electrification compared to their white counterparts. These are brand new studies, as you can see, and the typical white, male, high income, highly educated homeowners are the ones that are going for it. So you can see the uneven adoption of electric vehicles in different communities and different demographic, of course. And then even if you go to electric vehicles, and this is two studies that I bring as an example, you know, the first line I just directly took from the study that says EVs are not zero emission vehicles. And if you look at the right-hand side plot, you can see the tire particles, the brake particles, those dust particles or resuspended dust particles from the road. And electric vehicles compared to gasoline vehicles and diesel vehicles are emitting much more in terms of non-exhaust particles. And that has become an issue and will become a bigger issue in the future. That's why there is these international collaborations, for example, as I mentioned, with Professor Evans at University of Toronto, and many other researchers are focusing now on non-exhaust emissions, studying their particle size chemistry and then the exposure of population to non-exhaust particles. So that's the two aspects of electrification. So really what we want to say is that first of all, we need to work on transportation-related air pollution trap. You see, it's a persistent global challenge. It's going to be for foreseeable future decades. And even if we do electrify, there's still big challenges in terms of reducing air pollution from transportation, exhaust, non-exhaust, number of vehicles. And really, the impact of this kind of research goes really beyond academic publications. As you can see, we inform policies, we talk to people, we work with communities, just to see the impact actually is dispersed into communities and having a more sustainable, clean transportation and resilient transportation in the future of climate change. Part of our research, and this is something new. Part of our research is that we are trying to put together all of these tools that develop and make them available to municipalities, communities, government, whoever, researchers, academics, that they want to use it. So we are launching this software that is an emission calculator. Many of the outputs that I showed you in this presentation, you can actually generate with this tool easily. It's called Urban Transportation Emission Calculator, or UTEC. And if you're interested, just send me an email. We'll keep you when the launch happens, sometimes end of November, December this year. There's a soft launch to this software so everyone can get access and start using it. And if you scan the QR code, you can actually take a look at short video of this tool. But it's a very cool tool, mostly generated by my graduate students and put together by software developers. This is my email address and the QR code to my research lab if you're interested. And yeah, please reach out to me if you have any further question or you want to try UTEC. Thank you very much for your attention.
Thank you very much, Dr. Hosseini. Very, very fascinating presentation. Really interesting research. maybe to get the Q&A kind of started off, I was wondering if you could talk a little bit about how you're engaging with public health researchers or epidemiologists, for example, to kind of translate your air quality and emissions models into population health insights and policy recommendations.
Very good question. So on some of the projects, the results are being used constantly by public health researchers. For example, the study that we did in Tehran in terms of air pollution and emission, there are multiple papers came out after that in terms of health impact of the air pollution, respiratory diseases, mortality, morbidity. We did land use regression models of VOCs with public health officials. So the actual data and maps and the output of the model are being constantly used by public researchers. But we went beyond that. In one of the projects that I'm currently is in the Metro Vancouver project that I showed you a couple of slides, we actually work with a team of public health researchers at SFU and University of British Columbia. So these modeling results in terms of data is being directly transferred to health impact models. So what they do, they run our results into their health impact models to calculate mortality, morbidity, days of work lost, and every other health indicators as such. So really, it's a strong tie with the public health communities and officials. At the same time, in Metro Vancouver project, this is something that I have been trying for the first time. I'm the lead researcher in that project. But we work with the communities. We actually do all of the modeling, bits and pieces of the modeling that I just showed you in consultation with community. So there is a group of social scientists at SFU that they go into the communities. We case study city of Burnaby here in British Columbia. And we do a survey with the community. What do you like about transportation? What you're gonna, what is your future of transportation? Are you gonna electrify or not electrify, and why not? And at the same time, we show them the progress in our modeling and say, what do you would like to see in your community in terms of emission, pollution, health impact? So this is a community-centered research that we do with the public health. So as I have moved in the last 10, 15 years, I started to bring in or join collaboratively with public health researchers and members of the community to have more meaningful contribution and impact of my research.
Very, very interesting. Yeah, I think just visualizing the kind of the spatial overlap between air pollution and the incidence of respiratory illness, for example, just from a visual standpoint would be really, really interesting to look at. Grace.
Yeah, thanks, Vahid. I just want to pick you up on one of the interesting findings, the use of bicycles, vis-a-vis electric vehicles. And I'm just wondering the practicality of that, given that over the years we want speed now. This is the Gen Z period, technology, everything, fast. So how do we juxtapose that? I know in the Netherlands, they've done this over the years. They would rather put a bicycle on the road than even any vehicle at all before the advent of EVs and all that. So I just want to gauge your opinion on the practicality of probably reintroducing that in the face of the results that we're having from bicycle doing pretty much the same as EV in terms of emissions.
Yeah, very good question. If you look at that study that we are working on to get it published, we actually managed to capture the real world mode shift. So it's not like that all of the people one day decide to leave their car and then use bicycle. It's a small fraction. And that small fraction, they normally, and we have an agent-based traffic model, I didn't speak to that. So that actually captures the people behavior and then how they actually mode shift and why they do mode shift. And you may decide that, okay, I'm taking the car to downtown Vancouver. It's crowded. There's no parking. By the way, there is a free bike sharing system attached to my public transit. So if I take the bike to my public transit station, get the public transit, and over there's a bike waiting for me for my last and first mile trip enhancement, then I will leave my car and use combination of bike sharing / public transit. to reach to work, to reach to school. That's a very small fraction of population, but just leaving that car behind has a great impact. So the actual calculation is made based on those real small amount of shift, not a big shift. But you're right. The weather has an impact. You really don't expect people to bike a lot in Edmonton in December and January. Believe me, I lived in Edmonton. I know, and even not Edmonton. If you go to Burnaby, those steep hills in Burnaby, it's really you want to go back in SFU campus on top of Burnaby Hill. Good luck to go with the bike. So there are challenges of topography and weather, but you have to note that Canada is or North America in general, is a very car-centric society. We really don't give away or give up our cars easily, as opposed to Europe that is more condensed, is more bike-friendly.
Right.
So there is an opportunity. What we are saying is that there is a possibility, there is an opportunity, despite of the weather, despite of the topography. There are policies and changes that we started testing in our model that actually shows migration of people from using cars into alternative modes. And that shift is not big, is not like 10% of the population, all of the set could be 1%, 0.5%, 2%, but it still is a lot meaningful and brings down CO2 emission considerably, and it's doable within the context of climate and topography.
Thank you.
Thank you so much for the presentation. This is a clarification. The global report on waste linked waste generation to income. So if a country is generating a lot of waste, it means the GDP is likely to increase. So I wanted to know whether we can also link emissions to income or GDP of countries.
Good question. I haven't thought about this because I really, my research is not area. My best guess is that probably related to GHG emissions. And again, don't take this on from me, but certainly not to the pollution. Some of the most polluted cities of the world, they're not really doing well at GDP side. So if you talk about NOx pollution and particulate pollution, like toxic pollutants, probably not. I'm guessing that it will relate to GHG, but again, that would be my guess. Sorry that I don't have a straight answer for this one.
Thank you.
Maybe one final question, and you touched on it a little bit, Dr. Hosseini, but your case studies kind of span cities as different as Tehran and Edmonton and Vancouver. Can you share any insights on kind of some of the key contextual factors that most influenced, like the effectiveness of region-specific decarbonization and air quality strategies?
Sorry, I don't get the question. Can you elaborate a little?
Are you noticing any differences across the various cities that you're working in terms of what strategies are most influential on decarbonization strategies? If you're seeing any differences in kind of comparison across different localities?
Oh, huge difference. Huge, very good question. Huge difference. Here in Canada, for example, we are running a relatively new fleet. Just look out of your window. What type of cars you see on the street? They are, probably newer than 5 years old, right? And then they are relatively clean. And then electrification is just that one last step to remove whatever is left over through electric. Many cities that I have active projects and I go and I walk in those cities, the fleet is so old and so outdated that even jumping an emission level, let's say from Euro 2 to Euro 3 or from Euro 2 to Euro 4, it's a huge reduction in terms of emissions, GHG, everything, without needing that infrastructure of electric infrastructure that we need and, electric vehicles and everything that comes with it. So in that context, many cities are just improving the emission level, and I think it's valid and it should be that way. Electrification is not the solution for all of the cities right now. It depends on the context. It depends on the culture. It depends on the infrastructure. Imagine that you are in a country that most of the electricity generation is from coal burning or natural gas burning. Then why do you want to electrify vehicles? because you're burning coal to generate electricity to charge your electric car, and then you say that, oh, I'm doing fine. Oh, you're not. Let's burn gasoline and diesel. It's much cleaner than coal, and your impact will be less. So really depends on so many things. Cultural aspects. In one of the projects, in one of the cities that I have, most people are living in very small condominiums, high-rise, highly populated areas. There's no way that even if they go electric, they can charge their electric vehicles. There has to be different kind of approach to those cities. So really, it's contextual. It depends on the location, and we have to there's one solution not fit all. Really applies to electrification of the vehicles around the world. We have cities that they're running 20 years old, 30 years old truck for garbage collection, for example, or for public transit. Let's just get them, a new diesel truck. That will do the job, 100 times less pollution, CO2 and toxic and so on, in kind of immediate solution that fits the culture, socio-demographic, and infrastructure as they catch up to do electrification.
Wonderful. Thank you. Grace?
I'm thinking we may have a chance for one more question. I'm just curious about this issue of creating one solution and using it to cause more trouble, because I saw that one of your results was flagging the repercussion of EV vehicles, non-emission, you framed it, like non-emission based particles, that are being generated in one of your studies. So I just want you to probably speak a bit more on that. How can we avoid that if everybody, decides to go the way of EV, something like that?
So sorry, if I understand the question, what happens that if everyone tries to go EV, right?
Yeah, because there are now other consequences that you flag, that your results flag. You call them non-emission particles.
Non-exhaust.
Yeah. So how can we avoid that if everybody decides to go the way of EV?
Very good question, and I must say that collectively we haven't done any thinking about that. And this is very similar. For example, the example that comes to my mind is at some point of time, European decide to go, let's go all diesel light duty vehicles. You've seen the fraction of diesel light duty vehicles in Europe is much higher than any part of the world. At some point, the decision was that, we have super clean diesel vehicles. There's going to be less dependency on petrol and gasoline. Let's go all diesel. No one thought about the consequence of going all diesel. And in a matter of years, then, even clean European cities were facing black carbon and toxic diesel exhaust and NO2 on the roadside. And they are still struggling with that. So that was quite consequential decision. They pulled back on that one years later, but the damage was done. And I guess part of it was the pressure from diesel industry, vehicle manufacturers, lobbying, etc. I see the same trend for electrification. Let's just go electric. Let's electrify everything, and let's replace our big, huge single occupancy gasoline or diesel truck with big, huge single occupancy vehicle electric, and then feel good about the environment. You see the consequences. The congestion will be there. We're going to end up with a ton of lithium-ion batteries, recycling issues, environmental damages, non-road, waste of time in traffic. So that's why we do this research. That's why we try to inform policies that let's look at all of the solutions. Let's reduce the vehicles kilometers traveled altogether rather than electrify on a 1-to-1 ratio. That's not going to work out. And I don't think that we have really been thinking about that properly. So yeah, that's what I leave it there.
Thank you.
Thank you very much, Dr. Hosseini, and thank you everyone for joining us for today's science talk. As a reminder, all of our talks are available online on our YouTube channel and our website. And we look forward to seeing you next week for our next science talk. Thank you very much, everyone. Thank you, Dr. Hosseini.
Thank you very much. I appreciate it.